Welcome to the section on laws of sine and cosine, and a little more on area at the very end. The objectives in this section are to identify oblique triangles, effectively use the law of sines, effectively use the law of cosines, and finally find the area of a triangle given three sides only. Let's start with the definition of oblique triangles. We've used trigonometric ratios to solve right triangles, but now we need to look at the law of sines and cosines to enable us to solve oblique triangles. These are triangles that are not right triangles. Given at least three of the measurements, as long as at least one of them is a side. Keep in mind that given the measurements of the three angles, we can all come up with different triangles which are similar but not congruent. We have four, and if you consider the first one, 5 different scenarios for what an oblique triangle could look like, and given the different information, each one will be solved in a different way. Let's draw these 5 different situations with dashed lines for the unspecified sides or angles. In our first scenario, we have one side and two angles. We call this ASA or SAA, meaning angle side angle or side angle angle. So here is the first one. We have an angle side angle, and this is where you have a side defined and two angles defined, but the other sides are not. The two other sides are dashed lines. Note that the sides that are dashed are defined by the bold or solid lines. So these dashed lines will only be found given these solid angles and solid sides. The next one we could have is a side angle angle. And this one is where you have a random side of your triangle given. Both the angles are not connected to the side that's given. Maybe only one is. The next one is called a side-side angle. I have highlighted this one. Two sides and an opposite angle. Side-side angle. Notice that this may lead to no triangles, one triangle, or two triangles, and so this is probably where instructors usually spend the majority of their time when they get to law of sines and cosines. This one can be drawn in this way, where you have one side given, you have another side given, and you have an angle given. But notice that there is no defined angle for the other connection point between this side given and the other side given. We also have a dashed third side, and that means that if we were to define this second side that was given, I'm going to make it pink here because I want you to think about this. This pink side that I just highlighted, even though the side is given, the angle that I've dotted here could change, and when it changes, so would the third angle, and so would this dotted or dashed side. So this is the tricky one. This one has multiple different solutions, and we are going to talk about that further in a different video. So just maybe put a little star by this one because this is the problem child. Now let's move on to two sides and the angle is between. This one's pretty easy to define. It's side, angle, side. And this one always has two sides given, and the angle is always created by the two sides that are given. And so you just have to find that third side and those other two angles. Lastly, we have 3 sides given. So this is side, side, side. And of all the cases, this is the easiest to identify because you're never given angles for it. You just have the sides, and you know you will be using law of cosines because there are no angles given. And so it's just a very quick and obvious check. We don't know the angles, but they are defined by the sides. So they aren't necessarily open to negotiation, but they are never given. For the first 2 cases, and I kind of broke these 2 cases into 3 cases because I wanted you to see what the different scenarios could look like. For these first 3, we'll be using the law of sines. And for the last 2, we'll be using the law of cosines.